Okay, so for this chapter, we are looking at graphs involving the modulus function. Okay, so we will be learning how to sketch the graph of modulus y equals to modulus fx. Okay, the steps are basically to first sketch the graph of y equals to fx itself, and then to reflect the negative part of fx about the x-axis. So how do we do this? So remember that modulus itself is a positive function, meaning that if you draw the graph, right, it has to be always above the x-axis. Okay, so just recall that earlier we talked about, what is modulus x. So modulus x itself can be equals to x or negative x, provided if x is greater than or equals to 0 or x is negative. So it's the same for modulus of fx, right? If modulus fx is positive, then we just take the fx value itself, and if it's negative, then we take the negative of a negative of fx, which will become positive again. So in other words, every part of the graph that is below the x-axis will be reflected about the x-axis. So let me give you an example through question 3.1. Let's look at question 3.1, where we are drawing y equals to modulus x plus 3. So step 1, you notice that I draw the whole line of y equals to x plus 3, but the portion below I put it as a dotted line. But you can see that this is the entire function of y equals to x plus 3, and your y-intercept is 3, and your x-intercept is negative 3. Step 2, now the portion here is below the x-axis. Now remember, because it's modulus, right, when x plus 3 is less than 0, this is where we actually take the negative of it. So imagine if I have a y value here, that's for example, it could be say -1, then it's going to become 1, and similarly -2 will become 2, so on and so forth. So what happens is that you actually get a line that is reflected about the x-axis. So this is the new graph, and this green graph over here is y equals to modulus x plus 3, where you basically reflect the line segment below the x-axis above the x-axis, because now you must remember that here you need the y value is negative, but here the y value is positive, and we are talking about a modulus function. So just remember the two key steps. Number 1, sketch the graph. Number 2, reflect the negative part about the x-axis, and that is how you sketch modulus graph. Okay, so let me go through with you question 3.2. So for the graph of question 3.2, you also realize that if you sketch the graph very quickly, you may get a graph that looks some sort of that. This is basically sketching y equals to fx. Okay, the red color portion is if you sketch y equals to x squared minus 2x minus 25. Likelihood your x-intercepts will be 6.10 and negative 4.10. Okay, and this will be probably negative 25. So I have done step 1. Now step 2 is where I need to sketch the modulus graph. So how do we sketch the modulus graph? We basically keep the portions that is above the x-axis. So I'm going to indicate the blue portion as what I keep, and then I will reflect the graph about the x-axis. So you notice that now I've reflected the portion below the x-axis. This is now 225, and just to make it clear, I'm going to make it a dotted line graph, so you can see that now this graph is basically gone. Okay, so we can find the number of solutions. The next step is to find the number of solutions to the equation modulus x squared minus 2x minus 25 equals to 10. So how do we do that? Well, this is the one of the graph that was sketched. Now all you can do is we sketch the other graph, that is we sketch y2 equals to 10. If we sketch y2 equals to 10, then the point of intersection between the first graph and the second graph, this will give us the point of intersection will give us the solution. And we can see that if you were to draw the line y equals to 10, we actually are able to get 1, 2, 3, 4 points of intersection. So we can find the number of solutions by sketching the line y equals to 10 onto the graph of modulus x squared minus 2x minus 5. And therefore, as you can see that there are 4 intersections, you will basically have 4 solutions to the equation. Okay, so of course remarks, we can also solve it by using the algebraic method. I mean, if I can do this, I can use the same as what I did in part 2, that is equate to 10, or x squared minus 2x minus 25 equals to negative 10. Now solve this on your own, you will get x minus 5, x plus 3 equals to 0, and x equals to 5, or x equals to negative 3. Now solve this, you have x minus 7, x plus 5 equals to 0, and x equals to 7, or x equals to negative 5. So I will leave this to you, and you can see that 1, 2, 3, 4, this is basically the number of intersection and the number of solutions that you gotten. Alright, so just remember that the graph of y equals to modulus fx are obtained by basically keeping the portions above the x-axis and rotating the portions below the x-axis, which is how we get the new graphs here. Okay, so those in blue are those that I kept, and are those that are rotated, reflected, and those in red are the ones that I have kept. Okay, so with that, please continue and give question 3.3 and 3.4 a try and go through with your teacher in class. Okay, I will leave this to you to go through with your teacher in class. Thank you.